Okay, we were going to pick up where we left off on 4.1, looking at this construction company problem. So two construction companies offer different pricing structures. So company A is $5,000, that's their flat rate, plus $15 per square foot. Company B, $7,500 plus $12.50 per square foot. Construct a function to model the price structure for company A, right? So A of X, we read this, A of X equals, you start out with 5,000, every square foot, 15, right? 15 times X. X is the number of square feet. And A of X, what would A of X be? If X is the number of square feet, A of X is the cost, total cost, right? If I build a house that's 0 square feet, I don't have a house. But I paid somebody $5,000 to build it for me, didn't I? Okay, the second construction, B of X equals, what's the equation going to be? Yes, 12.5x. And you could put it the other way around. I heard you say 12.5x plus 7,500. That would be the same exact thing, okay? So again, we're using, now we can use a system because we're both thinking about square feet. They have the same, the variable represents the same thing. Assuming both companies do comparable work, which company offers the lowest price for a 800 square foot shop? I'm saying shop, but I was saying house. They're saying shop. Okay, what is the price? So we go A of 800. Now when we change the X to 800, we change the X here. 5,000 plus 15 times 800. $15 for every square foot plus the 5,000. How much does it cost for company A to build your shop? Who got the answer? 17,000. Okay, I'm going to trust you. Trust your work. B of 800 means that we're going to take 800 and plug it in for B. 1250 for every square foot. But ouch, they're charging me initial startup much higher than the other one. How much does it cost total for company B to charge to build your shop? 17,500. So those are slightly off. Which one is cheaper? Company A. Company A. Now let's look at what would be the company, which company offers a lower price for a bigger shop. So what are we going to do here? A of 1,800 equals 5,000 plus 15 times 1,800. And what was the price that you got there when you did all that math? 32,000. It's a much more expensive shop. B of 1,800 equals 7,500 plus 1,250 times 1,800. And what do you get there? 30,000. Okay, so now these are actually ordered pairs. If I want to graph these, which so it says here, for what building size will the two companies charge the same price? Solving algebraically and then versus solving graphically. So if I wanted to graph these, I have ordered pair here. Remember, I have a y-intercept. What's the y-intercept on company A? 5,000, yes, and here's 5,000. Okay, then you could even plot, like this is an ordered pair, 800 slash 17,000. 800, 17,000, 17,000, that's someplace in here, right? Ish. Yep. Okay, and so all I need is 2 points to draw a line if I have an ordered pair. Now I am going to put an arrow on this. Why would I put an arrow on the end of the line and not the beginning of the line? Exactly. You can keep building a bigger and bigger in house towards infinity. Well, you can never get to infinity. All right, now if I want to graph the second line, this is company A, so let's call this A of X. Let's graph company B. I'm going to solve it algebraically in just a minute. So company B, where's my y-intercept? Isn't it right here? Yeah, that's halfway in between, right? And then that they look like they almost meet there because that other one is only a tiny bit more expensive, and that's probably an inaccurate point as well, but that other one is just slightly, ever so slightly more expensive. Where do you guys predict they're going to meet? And probably my graph is off because I probably have that point a little too high. Okay, and to solve it algebraically, what we can actually do, this is kind of a Math 60 concept, and it's going to get us to our next thing. We could set this equal to this and solve for x. So we're going to set 5,000 plus 15x. We want to know, when is this cost equal to the 7,500 plus 1250x? I didn't put the zero. Is that okay? How could I solve that equation for x? What would you do? Mm-hmm. Right. Solve for x. So can I combine these? Are these like terms? No? So, oh, subtract 5,000 from this side. So the difference in their startup cost is 2,500. Well, what else would you do? 12.5x. Isn't that $2.50? So the difference in their per square foot cost. And then what would you do next? Divide by 2.5. 2.5. X equals, anyone? 1,000 square feet. So what's the solution here to the system? No, well, yeah. Okay, what kind of system is it? It's a consistent system because it has consistent. But I mean, what is the solution? Oh, okay. Oh, look, actually they did cross really at a nice location. My graph is maybe a little more. Yeah. So the solution is the companies charge the same amount for a shop that is 1,000 square feet, right? And that charge, if you plug in 1,000 to both of these, so let's just do that on our calculator really fast. If we plug in 5,000 plus 15 times 1,000, maybe you could do that mentally, you get 20,000. If I plug that into the other one, 7,500 plus 12.5, oops, times 1,000, I get 20,000 for both. So they have the same price. This is our solution right here, right? As an ordered pair, it would be 1,000, comma, 20,000. The companies charge the same amount, 20,000, for a shop. Okay, any questions on that, you guys? Moving right along then.